Good morning, guys. Today we're talking about osmosis and diffusion. Osmosis is the diffusion of water. And remember, these are in the cellular transport category. We're looking at the cell membrane and how molecules move across it. So osmosis is the diffusion of water through the semi-permeable cell membrane. Osmosis doesn't refer to any other substance but water. No other substance can undergo osmosis. Diffusion is simply the movement of molecules from an area of high concentration to an area of low concentration. Those molecules move based on the temperature and the size of the molecule. Now, imagine, if you will, if a molecule is smaller, it moves faster. Also, if a molecule has a higher temperature, it moves faster. Think of boiling water. The molecules in the boiling water move much more quickly than the molecules in very cold water that you would take out of your refrigerator. The concentration gradient simply refers to the fact that molecules always move, they have the tendency to move from an area of high concentration to an area of lower concentration. So let's look at how it works. The cell is a closed structure and it's protected by its cell membrane. And the membrane only allows certain things in or out depending on their size and or their charge. Water can enter or leave whenever it wants. And that passage depends on the concentration of water on either side of the cell. So osmosis begins, and if you look here at your cell, this is the cell membrane with the phospholipid molecules, and we've looked at all of that. You'll notice that there are molecules on either side. The overall tendency of the molecules is to move to the area where there are fewer molecules. Osmosis is always occurring in both directions. So when we talk about the water moving, it's just more water, or the net movement moves from higher concentration to the lower one. So notice there's always water going both ways, but if there's more molecules are bouncing off of the cell membrane, and so more molecules are going to go to the other side. And this continues until there's a balance. When there's a balance of concentrations on either side of the cell membrane, osmosis still occurs. Water still moves back and forth, but the net movement is unchanging or equal. That occurs at a slower rate to maintain the balance. Obviously, there's no initiative for the molecules to move, so they move more slowly. In a hypertonic solution, and guys, think about the egg lab, okay, or the egg demonstration that we did. In a hypertonic solution, the concentration of solutes outside is higher than the concentration of solutes inside the cell. So think about the demo when we were looking at the egg in the syrup. What happened to that egg in the syrup? The water diffused out. If a cell loses too much water, it shrivels and shrinks. So here's an example. If you take a piece of lettuce, just regular head lettuce, and put it in a bowl of salt water, you're going to notice that the lettuce wilts, okay? If you put lettuce in salad dressing, a lot of times let it sit for a while, it'll get wilty and flaccid. That's because the water moves out of the lettuce and the cells in the lettuce and into the hypertonic environment where there's lots of salt and not as much water. In a hypotonic solution, think about this one when our egg grew and grew and grew. A hypotonic solution is the concentration of solutes outside the cell is lower than the concentration inside the cell. And so water diffuses into the cell, causing it to swell and sometimes burst. So if we stick our lettuce, again, into a bowl of distilled water. Why distilled? Because we take the minerals and all of the solutes out of distilled water. So that makes the tendency of the water to have no molecules in it moving into the lettuce. It gets very firm and crisp. Okay, think about celery. If it's in your refrigerator and it's getting a little bit limp or not crisp, you put it in a bowl of water and bam, you have crisp celery again. Same thing. This is because of the hypotonic solution. Now, a solution that is isotonic means that the solutes inside the cell and outside the cell are equal, so the cell retains its shape. In this particular case, we take a look here, and with regard to isotonic, just think about the fact that you use saline solution when you put your contact lenses in. That's because you don't want your cells dehydrating. You want the solution to be the same concentration, which is slightly salty. So if we look at osmosis in plant cells, the cell wall prevents the cell from bursting if it's in a hypotonic solution. So instead, we get a lot of turgor pressure, and the water pushes against the cell wall, making the cell very stiff or rigid. That brings us to a question: why do saltwater fish die in freshwater? Well, if you think about their cells, and you think about the fact that saltwater fish normally live in a saltwater environment, the cells of the saltwater fish are hypotonic to the freshwater that surround it. So the water moves into the cells and causes them to swell and burst. The gill and the blood cells die, and eventually that kills the fish. Now, if I put a freshwater fish into saltwater, a similar but opposite phenomenon will occur. The cells of the freshwater fish are hypertonic to the saltwater. And so the water moves out of the cells, causes them to shrink, and the gill and blood cells die, eventually killing the fish. So take a look here. If we have a 5% salt solution on the outside and a 3% salt solution on the inside, why is the water leaving the cell? Well, take a look, guys. There's more solutes outside the cell. So in order for the water to re-enter the cell, you need to dilute the solution on the outside of the cell. So the 3 and the 5% represent the amount of solutes in the solution that is present. Thanks for listening, and let's go ahead and continue with our osmosis and diffusion episode.